In this video, we're going to calculate the surface area and volume of both prisms and cylinders. And we're going to do the shapes in just a single video because, as we're going to see, the formulas that can be applied to both are going to be the same. What we see here is a cylinder, and next to our cylinder, we have what is referred to as a 2D net of the cylinder. In other words, a two-dimensional representation of its surfaces. And what we'll recognize is that the bases of the cylinder, as we know, are circles. And the radius of this circle is given as 4, and it's going to be the same on the top and the bottom. And this surface that goes around the cylinder, what is referred to as its lateral surface, the surface that connects the two bases, is in fact a rectangle that has been rolled up around the circles. We're told that the height of this lateral surface, this rectangle, is 8, and we might want to then think about the calculation for its length or its width, the base of this rectangle. We know that it has to roll up around the cylinder, so this length should be equal to the circumference of the base. Circumference is 2 pi r, so 2 pi times 4, or 8 pi for that length, which is going to be approximately 24, 25, but we'll leave it as 8 pi. We want to calculate the area of these shapes. Well, first we'll calculate the area of the lateral surface, and that's base times height, or length times width, which is equal to 64 pi. This is what we're going to learn to call the lateral area, or we'll use LA for short to represent lateral area, and it is the area of everything that isn't a base of the figure. All right, the area of our bases, they're circles, so that's pi times radius squared, or 16 pi. And we're going to use the capital letter B to represent the area of base. Lowercase b means the length of a two-dimensional base. And so we've got, or one-dimensional base, so we've got a two-dimensional circle here, so its area is 16 pi. There are two bases, so 2 of them is a total of 32 pi. And so we're also going to refer to then the surface area of this figure, which is its lateral area and its bases put together, everything. The textbook calls this total area. Some textbooks, other textbooks will as well. I'll typically refer to it as surface area. Surface area is equal to our 64 pi. We wrote our lateral area wrong earlier. It's not 8 pi, it is 64 pi as calculated for the rectangle. And our surface area is going to be that 64 pi plus the 32 pi, or 96 pi. Let's do an example with a prism instead of a cylinder, and we'll see how the approach is similar. So we've got two triangular bases, and we have a two-dimensional net for our prism, shown to the right. What makes this a prism is we've got two polygons that have been connected by rectangles. And the three rectangles that make up the outside of the figure, we see the front-facing rectangle here, are represented by the rectangles in this two-dimensional diagram. We know that their height is 9 and their base is 6, and that it's 6 for all of them because the base of our prism is an equilateral triangle. And we know that the area of one of these is 63. That means our lateral area is going to be equal to 63 times 3, or 189. Now there is a bit of a shortcut that we could have used. We could have thought of this as one large rectangle, in which case we would wanted to have found the area using 18 times 9. So it has a height of 9, but now has a base of 18. And this 18, what it represents is the perimeter of the base. Much like in our cylinder problem, our rectangle had a width that we called the circumference of the base. circumference just being the word for the perimeter of a circle. So a shortcut formula then can be to take the perimeter of the base and multiply it by the height of the prism, and that gets you your lateral area. Let's also solve for the bases. Each base is an equilateral triangle. So base is going to be equal to 1/2 b times h. We already know b is 6, and we need to calculate h. So we want to use what we know about equilateral triangles to do this. Primarily, we need to use the fact that we know that an equilateral triangle, when split by the height, will create a 30, 60, 90 triangle. If the hypotenuse is 6, which we know because it's equilateral, then this 30-degree side will be 3, and this 60-degree side will be 3√3, which is in fact the height of our equilateral triangle. So the area of the base is 1/2 times the base of the triangle, which is 6, times the height of the triangle, which is 3√3, giving us 9√3. So our surface area can be calculated as 189 plus 2 bases, since there is one on both top and bottom, 18√3. And we'll just leave it like that in order to have an exact answer rather than rounding using decimals with a calculator. So to summarize, shortcuts for right prisms and cylinders, if you want to calculate the lateral area, all you have to do is the perimeter of the base times the height. Now, if this is a cylinder, typically you'll see this written as circumference times height. And it is key that for both P and C, this refers to the base of the figure. For surface area, the only difference is we want to include the 2 bases of our shape, and so we usually just refer to this formula as the lateral area plus 2 times b, remembering that capital B means the area of the base. And you'll have to use whatever area formula is appropriate for the base, depending on if it's a circle or a square or a triangle or whatever is referred to in the shape. Let's talk a little bit about volume as well. And before we talk about volume, I want to kind of compare it to 2-dimensional shapes first. This is a rectangle, and b, in this case lowercase b, represents the length of its base, and height represents how tall it is. And its area formula is equal to base times height. And next to it we have a parallelogram that also has a length of b, and let's say that those are the same. And its height is measured here on the interior of the figure. It could also be measured over here on the exterior of the figure, but usually we measure it on the interior. Represents the distance between the 2 bases. And if this is h, its area is also b times h. So despite one of these figures being slanted and the other one being vertical or with 90-degree angles, their areas are going to be identical as long as their bases and their heights are the same. Now, if we think about what this shape is made up of, that might make a little bit of sense. If you imagine that a rectangle is instead a stack of segments, you can imagine that calculating its area is based upon 2 different things. One, how long are each of these segments, in our case, B, base, and how high is the stack? How high we make the stack will affect how big of a region is covered by this stack of segments. Now, when we go to the parallelogram, we'll notice that the exact same thing is occurring. This parallelogram can be thought of as a stack of segments. However, instead of the segments being stacked directly on top of each other, forming 90-degree angles, they're kind of set off to the side just a little bit, creating this kind of slanted figure because they're not lined up directly above one another. However, the length of every segment is still the same as the length of all the segments in the rectangle, and as long as we stack these segments to the same height, then it should cover the exact same area. Well, the volume of a prism and cylinder can be thought of in a very similar way. Except instead of stacking segments, a prism is going to be a set of polygons that are being stacked on top of each other. In this particular example, we're stacking a bunch of rectangles on top of each other. But the idea still holds. If we can figure out the measurement of one of those rectangles and then multiply by the height of the stack, we would figure out how much space is taken up by all of them put together. And we know how to do both of those things. The area of this base, or this rectangle, is 4 times 3, or 12. And the stack has a height of 7. So the total volume taken up by this figure is going to be equal to 12 times 7, or 84. In the case of the cylinder, the stack is made up instead of circles, but the idea still applies. If we can find out the measurement of one of those circles and then multiply by the height of the stack, we will figure out the volume of the shape. And so the area of one of those circles is, given that it is a circle, pi times radius squared, or 16 pi. And the height of that stack is 8. So we know the volume of our shape is going to be 16 pi times 8, or that is what, 80 plus 48, 128 pi. And both of these can be simplified into the same kind of formula. To calculate the volume of a prism or a cylinder, you want to know what the area of the base is, and you want to multiply by how tall the stack of those shapes is.